The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on Parkade exhaust systems. My name is Sherry Adams, and I will be moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined this Tech Talk, an attendee control panel appeared on the right side of the desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing the icon allows you to minimize or maximize the control panel. When maximized, you can use the control panel to submit questions. We'll be gathering any questions throughout the presentation, and we'll leave a little time at the end for Q&A. If your question is related to a particular slide, please include that number of that slide in your question. A PDF of the slides from this presentation will be sent electronically to all those who are registered for today's Tech Talk. We will also be recording this Tech Talk and will be available on our website under the Resources section. The new password to access this Tech Talk is TechTalks18. That's capital T-E-C-H, capital T-A-L-K-S 18. Today's Tech Talk is from Kevin Thurston. Kevin is the owner of Thurston Engineering Services located in Saskatoon, Saskatchewan, Canada. Kevin is a professional engineer, certified energy manager, and certified commissioning professional. He has been commissioning throughout Canada for more than 17 years. Kevin is the past president of the Western Canada chapter and is currently the vice president on the board of directors for the BCCB. Kevin's most recent projects include the Remy Modern Art Gallery of Saskatchewan, the Saskatoon Police Services headquarters building, and over 1 million square feet of schools last year. So Kevin, I will turn this Tech Talk over to you.
Thank you very much, Sherry, and thank you to everybody who's attending today. In my presentation today, talking about Parkade exhaust systems, first of all, in Canada, we call them Parkades, and basically it applies to any type of covered parking garage, whether it be underground or above ground. In my talk today, I'm going to talk about the calibration of the sensors, the mounting heights, the space separation that they should have in terms of the square footage in the parking garages, the toxicity levels of CO and NO2, the alarm levels that you would be looking for, the commissioning of the makeup air system, the MUA, and the exhaust fans, and the dampers. So throughout the rest of the presentation, I'll be referring to the ventilation as MUAs and exhaust fans. I'll talk a little bit about the test and calibration gas, as well as finish it off with the top 10 most common commissioning issues that I see when I'm commissioning these systems, and then any questions that you may have. You may ask yourself why we have above ground and below ground parking garages in Saskatchewan and in the colder climates. We typically get temperatures in our winters here that exceed -50 with the wind chill, and we find that people are going shopping or going to their condos and whatnot, just don't want to walk through that kind of weather. I don't blame them. So these systems are not usually something that people consider very often. They're almost invisible to everybody, but once you start getting elevated levels of these poisonous gases, people do start complaining of headaches and whatnot. And every underground parking garage has them. You're just not seeing them. Land is at a premium where I live, so quite often our condo units and shopping centers don't want to pay extra taxes for the above ground, so they build all the parking stuff underground. This would not be applicable to open air parkades. So the calibration of these pieces of equipment, these sensors, are usually performed by a qualified testing agency, but more often than not, prior to substantial completion, we see it's the controls contractor that is doing it at the end of the project, since they're typically the ones that are supplying the sensors, whether they're getting them through Honeywell or some other company that provides them. We calibrate them usually to about 200 ppm for the CO and 5 ppm for the NO2, and that's typically what we see in Saskatchewan for parkades. If it's just a little parking garage like in a police station where they're bringing in prisoner transport, those levels are usually a little bit lower on the CO, down to 100 ppm. They need to be calibrated and tested annually by code up here, and it's important to know for your local codes whether or not you only need to monitor the CO and NO2, or whether or not you also need to monitor things such as carbon dioxide or others. In Saskatchewan, we don't allow propane-powered vehicles or natural gas vehicles in our parkades, so there may be other gases that you need to monitor for, and you would need to know what the calibration levels are. So throughout this presentation, I may talk about a calibrated level, which is the 200 parts per million and 5 parts per million. I'll talk about a warning level, which will be less than that, as well as an alarm level as we get into the other slides. It's important to realize, though, that the 200 is a calibration only. So moving on to the mounting heights and the location, the carbon monoxide sensors go into the area 2 breathing zone, which is about 4 to 6 feet off the ground, whereas the nitrogen dioxide sensors are anywhere from 8 inches to 6 feet above the floor level. And what determines that is usually the type of diesel vehicles that are going to be in your garage. If it's more of a service vehicle that have the top exiting exhaust stacks, you're looking at higher elevations for the mounting height. And if it's more like just diesel cars, you're looking at lower ones. Typically, we see the NO2 sensors, though, up near the ceiling because the NO2 rises. It's important to confirm your mounting heights and the maximum distance between the sensors in the parkade or in the parking garage with the mechanical design engineer and your city inspector or authority having jurisdiction. We quite often see on the design reviews from the mechanical design drawings that they're just showing a sample of what the sensors are that are required and not necessarily getting the proper distance. And the last thing you want is to have more sensors having to be added when the city inspector comes in, which actually did happen at our REMI art gallery. You do want to make sure that you locate these away from any kind of ventilation fans so that when they're reading the CO or the NO2, that is not being diluted and giving maybe not giving you the exact value that is actually in the parking garage. So on to the toxicity levels. You can see that on the toxicity levels, the lowest that is shown on this table on the bottom left-hand side is 200 parts per million. And if you recall, that is actually what I said is our calibrated amount. We never expect the CO to get that high unless someone's maybe idling a vehicle right underneath one of the sensors. And it takes an awful long duration even to start feeling any kind of health effects from 200 parts per million. You can see 2 to 3 hours. And then as we elevate up, the health effects get more and more. And this little pictograph kind of shows how a person can feel from being exposed to durations of various levels. You can see on this, it's just at 500, which we would never expect in the garage. At 20 minutes, you're just starting to feel some noticeable symptoms. For nitrogen dioxide, it's completely different. This one from the diesel fumes is far more lethal, and it doesn't take as long of an exposure. You can see at as little as 0.2 ppm, you're getting some lower respiratory, and as we move up to the 5 ppm, which is actually the calibrated amount, you're getting significant health issues. So what we basically do is you alarm at a lower level or warn so that you start your ventilation equipment, and then as it rises, we alarm. And we actually alarm somewhere in between this 1 and 5, typically at 2 parts per million, so that people aren't getting that. So alarm levels for CO, this is from various codes in the US for standards and regulations of where you would start. 9 is too low, but anywhere from 25 to 50 is where you can start doing your low limit. As I said, we start our ventilation equipment, our makeup air units at 25, and then if we hit 100, that's where we alarm. For the NO2, it's at 0.5 parts per million, and then we alarm at 2. We never expect it to get up as high as 200 for CO or 5 for NO2. If it does, you have a problem. So this screenshot here about the Parkade alarm levels, it's important to know what you need to do for your building. The stage 1 is 25 parts per million of CO, as I mentioned, and 0.5 parts per million of NO2. And what that triggers is your ventilation equipment would actually come on. This screenshot right here is from the building automation system and shows that at 25, this is when our ventilation system would begin a countdown timer to actually shut down. So we've gone up above the 25, activated the ventilation unit, then once it comes back down below 25, for 5 more minutes that unit will run to bring in fresh air. For NO2, we would be looking at 0.5. You can see that on the snapshot, it actually says 2.0, which was an error caught during the commissioning process. At the stage 2 alarm, not only will your building automation system generate alarm, but you will get a very loud audible alarm on the CO sensor or the NO2 sensor, which is very difficult to silence, which we found out while we were getting these snapshots. So this would occur at the 100 ppm for CO and 2 ppm for NO2, and then as they begin to drop, as I mentioned right in here, this is when our countdown timer starts, and you hope that by the time it shuts off that the gas levels are back down into the safe zones. And a very important thing to do prior to your gas testing is to do your pre-functional checks on the actual exhaust fan and makeup air unit system. First thing that you would do is make sure when everything is shut off that the exhaust air dampers are closed. Then once you've made sure of that, you make sure the exhaust fan is not operating and the makeup air unit is shut down. On a call for it to be open, you must make sure that these exhaust dampers do open, prove open, and then the exhaust fan starts. Once the exhaust fan has started, a signal goes to the makeup air unit, which, forgive me on that. Once it goes to the makeup air unit, this is usually an internal control that the controls contractor has no control over. He can only enable. So you have to make sure that the outdoor air damper opens and then the supply fan starts. Otherwise, you will not be bringing in outdoor air. Because we get very, very cold winter temperatures, this unit could be running already because it's trying to keep the temperature in the parking garage, which we try to keep at about 45 Fahrenheit or just over 7 degrees Celsius. So as I said, make sure that this is all off. The system is completely off and the dampers are closed prior to your testing. And then I went through the sequence of what happens as it does go. So we made sure that this was all shut down and not operating for either gas or the temperature set points. So on a CO alarm for testing, you can see here on the left-hand side I have actual snapshots of the gas sensor itself, and then the right-hand side is a screenshot from the Johnson control system that shows that the elevated levels got up to 120 on the BAS, and it did have an alarm. So we got the warning at 25, which does not change color. That activated the makeup air system and all the exhaust fans. And then when it hit above 100, we did get the elevated alarm. You'll notice here that on the left-hand side in the top snapshot, the sensor was actually reading 183 parts per million, and on the BAS graphics, it was only reading 120. This was just due to network lag and a sampling rate. It did eventually elevate up until this level before we turned the gas off so it could switch over to NO2. So the NO2 alarm, as we tested that, at 0.5, we had the activation level of the makeup air system coming on. And then at 2.0, we did get an alarm, but you'll notice during this commissioning right here that at 4.5, we still didn't have the red background, so the building operator was not getting an alarm that this was exceeding its value. What had happened here was there had been a software upgrade to the system, and values that were input for alarm levels went back to pre-commissioned values. So that's something that we had to watch out for. So the test calibration gas kit, this is something that you can purchase through any of the local gas supply companies that have this type of gas. What you would want to get is a kit that contains a CO gas canister with 200 parts per million and a nitrogen balance, and the nitrogen dioxide would be at 5 parts per million with a nitrogen balance. Stay away from caustic nitrogen dioxide because that increases your cost significantly. You need a fixed flow regulator as well as at a specified amount like 0.5 liters per minute. The cost of the test kit can range. I got mine for right in around $700 Canadian, and that's because I shopped around. I tried to go through the local controls contractor, and they tried to give me the caustic one, so I needed a second regulator. That put it up to about $1,900, but then I got one from just one province over, about 800 kilometers, and I was able to get it for $700. So the closer you can get it, the better, because this gas has to be shipped by ground. It can't go by air, so that will reduce your shipping costs. So moving on to the final portion of this, the 10 most common commissioning items that I've run into are the mounting heights are not correct. The sensors are swapped. Someone has gone and moved the CO sensor and the NO2 sensor and swapped them. There haven't been a sufficient number of sensors. That's where I said to check with your city inspector or the authority having jurisdiction and make sure that you know how many need to be there for when you're doing your commissioning. the sensors were not calibrated correctly at the, or arrived in the field not calibrated correctly from the factory, so they have to be set up. The alarm levels were not programmed at the device. It does vary from province to province and state to state, I'm assuming, in terms of what levels you have to alarm at, so getting those correct is important. The most common one is alarms are not programmed into the BAS yet, that the controls contractor has forgotten to do that. The sensors are not linked to the makeup air system, to the ventilation, so even though they are reading high levels, it's not starting up that ventilation equipment. Not connected to the correct makeup air unit system. In the Remy Modern Art Gallery, it's got 2 sub-levels of parking, and there are 4 such ventilation systems with about 4 sensors connected to each one. And when the pre-commissioning was done, the incorrect makeup airs were actually starting up. Incorrect gas levels, as you saw on my screens, being programmed into the BAS, where the countdown timer was not starting at the correct amount. And software updates to the BAS system restored original gas set points to a pre-commissioned value, so you have to be careful of that. And so that kind of wraps it up, and I'm now open to any questions if there are any.
Thank you, Kevin. I'm not seeing anything right at this moment, but let's give it just a moment because something may come in here.
Okay. I apologize for the slides slipping. For some reason, they kept wanting to advance and go back without touching the screen.
I did just have, forgive me for a second because now my screen just got smaller. So 1 second here. Okay. Second. All right, Kevin, have you run into trouble with air temperature and having the calibration gas not work?
Run into issues with the temperature inside the Parkade? I'm going to assume that's what they mean by that. No, because typically the makeup air units, they're like a gas-fired heat exchanger, so the temperature is kept pretty consistently at 45, and you are getting a lot of heat off of the vehicles that are coming in and out off of the engines. So we have never run into that issue with the calibration gas being off because of temperature. Like we're typically even near the door, we're able to just wear short sleeve shirts like Visi vests and whatnot. We're not in like having to bulk up. There are usually like air curtains or some form of an air movement fan right at the front of the door to make sure that the cold weather isn't penetrating too deep into it.
Okay, great. We have another question. How do you work with the mechanical design consultant?
So off the drawings in the Parkades, they will usually show the sensors. So we would ask them just a simple question in terms of how did you base how many sensors you needed in the Parkade. So for the sample that I showed for the art gallery, the consultant was actually out of Ontario, and the art gallery is located in Saskatchewan. So his design actually was for the codes in Ontario, whereas ours were a little more stringent, and we needed to add, I think it was 1 to 2 sensors per one of the 4 zones on that. So it's just a matter of asking a question of him, and then they can tell you what it is. And where this is a City of Saskatoon facility, we were able to get the city to ask their city inspector how many sensors they would need.
Thank you. Okay, we have a couple more questions here. How often do the NO2 and CO sensors need to be recalibrated?
I know for certain that any type of living unit, like in condominiums and apartments with the underground, that's annually. And then I know at the art gallery as well, they're doing it annually just to make sure. So I think if it's any public facility, here in Saskatchewan anyways, it's on an annual basis. And I know it's the same in the province to the east of us because I've done work in that too in Manitoba.
Okay.
That's a code thing. Like that's where you would need to know from your code officials how often.
Okay, thank you. Next question, is the ambient CO2 reading outside the building monitored too?
No, it is not, because typically these sensors are right at 0. I think you would have to if you were doing CO2, because that would be more of like in around the, up here it's around 400 parts per million for ambient. But our ambient CO is, I believe it's diluted enough with fresh air that it would be right in around 0.
Okay, and then this looks like this may be our last question. Any concerns or idea on what would happen to the system if the garage temps are below freezing?
The sensors are rated to much below 0 here, so it would probably be close to about -20 that the sensors can handle. Again, though, I'm not 100% certain because we've never had to deal with temperatures that cold. So there's a possibility, I guess, but the canisters themselves are rated to being in cold weather because I think that's all we can get up here.
Great, Kevin. Well, I think that is the last question that I am seeing here. And as a reminder, because I think one question was for me, you will be receiving a PDF of the slides of this presentation, as well as it will be available electronically on the website under the resource section of our website. So with that, Kevin, I thank you, and we really appreciate your time and expertise today.
Thank you.
Thank you, everyone.